Hello and welcome to the Section 8.4 application walkthrough. In this unit we were looking at special case systems of equations, and so let's go ahead and look at solving these two problems. Okay, the first one here just looks like a standard systems of equations problem. You can solve it any way that you want. I'm going to go ahead and multiply the top equation by 2 and work with elimination. Okay, you can use substitution if you wanted. I'm just going to do it this way. So multiplying x by 2 is going to give me 2x. 3 by 2 will give me 6y. And then negative 2 there. And I'm just going to copy down the second equation and see what happens. When I add these two equations up, the x's go away, the y's go away, and I have 0 equals 6. Well, that's a false statement. And since it's false, we learn this unit that means that there is no solution. Okay? And for no solution, that means that you have two parallel lines that never cross. Okay? For number 2 here, we actually have what's, it's a bigger system of equations. There's 3 equations and 3 unknowns. All right, now it takes a little bit of work, but what I'm going to do is I'm going to help you get down to 2 equations and 2 unknowns, and then let you go from there. Okay, and that's the way that you solve any more complex system, is get it down to 2 equations with only 2 variables, and then work from there. Okay, so I am going to come up with 2 equations where I get rid of one of the variables. Okay, the variable that I'm going to pick on at first is y. If you notice that all the y's all have a coefficient of positive or negative 5. So I'm going to make one equation. I kind of always look at these as equation 1, equation 2, and equation 3. And I'm going to make one equation by going equation 1 plus equation 3. And then I'm going to make another one by going equation 2 plus equation 3. And that's because 3 has a positive 5 and the other 2 have negative 5s. Okay, so let's just look at 1 and 3. It's negative x minus 5y minus 5z equals 2. And then this one is x, looks like plus 5y minus z equals negative 20. Now I can add those straight down. Okay, when I add them straight down, I get, looks like x's go away and y's go away, and I know that negative 6z equals negative 18. Okay, that was actually sort of a special move there, since the x's canceled themselves out also. I know now that if I divide by negative 6, okay, that z is positive 3. So my, and this happens sometimes when you're solving equations or, working out a problem, that your method can alter at any given point. Okay, really what I have here, since I know what one of the variables is right now, that I can plug that z in to any of these equations and come up with 2 other equations with x's and y's. Okay, I'm going to pick equation 1 and equation 3 just because I know that I'm going to get something that'll work out. Okay, actually no, I'm going to do equation 1 and equation 2. So what I mean is I'm going to go negative x minus 5y minus 5 times 3 equals 2. And I'm going to solve that equation, just meaning that I'm going to have x and y on the same side here. So that gives me negative x minus 5y minus 15 equals 2. When I move the 15 over, that's going to turn that 2 into a 17. So that's equation 1. Let's look at what happens to equation 2. So that's 4x minus 5y plus 4 times 3 equals 19. So just copy down what I have and that'll be plus 12 equals 19. When I move that 12 over, that'll be subtracting 12. And so I'm going to get 7 for my after the equal sign there. So now I have two equations with two unknowns right here, and I'm just going to write that for you, and I'm going to let you take over from here, and we have 4x minus 5y equals 7. Okay, there is your new system of equations. Go ahead and work from here to figure out what x and y are, and then what you're going to want to do is put your answer, maybe somewhere down here. You're going to have x, y, and z, but we know z is 3. Okay, that's what your answer is going to look like. So go ahead and work that problem out and figure out what you get. If you have any questions, feel free to let me know. Other than that, good luck on the Mastery Challenge, and we'll see you out there.